Here we go again. There. Mini. Okay, so let's make a video. And I haven't been making too many videos lately. So this video is about my Mini. And this Mini started as a, believe it or not, a very stock Low-Z Mini Pro, and it kind of snowballed out of control. So the only thing that are stock now is the gearbox and the central part of the axles, front and rear. Everything else, yeah, it's a bit different. So let's start with the drivetrain, which is the most complicated. So I've done all this project in SolidWorks, and I was a bit bummed, I was a bit pissed off that there was no underdrive for the Low-Z axles, and I decided to make my own. So to do that, I designed two gearboxes, one on the rear, one in front, and these gearboxes, they have underdrive, they have 32 pitch pinions. I don't remember the tooth count on them, but yeah, overdrive, underdrive, and this creates these really funky shafts, a bit too twisted, but they don't bend. They are SDI shafts for Mini, so 4mm and 4mm. They work really well, they don't bind, so it's good. Other stuff, yeah, I design also these adapters on the front axle, on the front axle, so I can use then, so I can use these adapters, so I can use the C-hubs from a AX10 or SCX10, the first generation, and then Bully 1 knuckles that were modified to fit these C-hubs, and then I designed and 3D printed these knuckle weights, and it's nice, it's enough weight. The first iteration of this, I had some all brass deluxe knuckles, and it was too heavy, too front heavy, and because this car doesn't have too much acceleration, to get out of while going downhill was extremely tricky. But yeah, so the shafts, they are the cheapest I could get shafts. They were like $5 or $6, 1/8 TT shafts, and I just cut them to length and cut my own the tang and all that. So as you can see here, they are 8mm stub. The hubs, this one, yeah, this slop is actually on the bearings, between the shaft and the bearings, but this one is a bit worse, and this slop is on the hub itself, because I rushed it. Basically, it's made out of magnesium, because I was working in a factory where we were making magnesium injection, and out of the molds there was some pieces for the robot to grab, basically leftovers. So I just cut and then I machined this, but I was rushing on this one. The other one was the first one. I took more time, and yeah, this one was a bit bad, but still gets the job done. It's fine. What else? So yeah, front axle is like that. Rear axle, let's do a switcheroo. I made, so all this was home printed, and so far so good. I've made this rear upper link mount, and it has served me well. So far so good, no failures, and I have more adjustment. The lockouts, I print some lockouts as well. They have just one piece shafts on the rear from the Pro. So this is still, if I remember well, this is all still lossy. I think it is. Or did I make some custom shafts? I don't remember. I think it's all lossy. I just made this so then I could have the weight hanger there, the lockout with some weight hanger. I don't know if you can see. The hubs, the wheel hubs on the rear, they are 3D printed at home. So far so good. This is a relatively light rig. I think maybe 1.6 kilos. I don't remember exactly. But it's very front heavy. All the weight is in the front. Very light rear. I think around 66% in the front or something like that. So moving to the center part. Yeah, lossy gearbox. Again, one of those. This is just for testing the fitment kind of deal. And I 3D printed, because I have this bigger motor, I 3D printed this motor mount, and yeah, it has been working great, not skipping any teeth or anything, so it just goes with it. So I just kept it. Chassis is a bit new. I had an older version of this chassis, which is somewhere. I'll grab it. Yeah, so this was my original chassis, and the shock mounts, they can swing up and down, but I realized that these were too low. Okay, these were too low, so I 3D printed these upper parts with some shock mounting on top, so I could get the chassis lower. I could lower the chassis, and this worked better. I liked the stance more. The suspension seemed to be working better, so I decided to build the second version of this chassis. But since we are here, we can talk about the skid and how the gearbox is mounted, because the gearbox, this is all black, it doesn't help, but anyway, I'll try my best. So the skid, this part is obviously the skid, but there is this plate here. I don't know if it's catching on the GoPro. Yeah, so there's this skid here. Everything is black, unfortunately, and this part is at an angle, and that angle is in a way that the motor basically sits as low as possible here, because on the, if I just put it flat, the motor would be a few millimeters up, and I didn't see much of a point in that, so I decided to make the skid in a way, I don't know if you can catch, like this plate here sits at an angle, and that angle is enough to lower the motor a few millimeters. Why? I mean, why not, since I'm going to build this from scratch? And also we can see here that this also offsets the gearbox to the driver's side, because if I put the gearbox central, the motor would just be hanging on the passenger side, and that's not ideal. I tried to keep the weight as central as I could and at the same time have a really short skid, and this way I kind of manage this. With the lossy gearbox, the shafts come out here and they come out extremely close to this side, which is tight, but if the pinion is in the middle, should work fine. I think even if it's in the passenger side, in the driver's side, should be fine, but it's a bit more dodgy. Depends, I think, on the drive shafts. Anyway, I retired this chassis, so that's gone, and I've made this one with what I learned from the previous one, of course. So all these shocks, everything, all the chassis is different, because when you start moving, you move one thing, then you move the other one, and in the end you have to move everything. So yeah, since I don't have a lathe yet, making these spacers here on top, they are a bit difficult for me. I mean, I'd have to do with what do you call that, drill press, which the accuracy is close to 0, but yeah, I got them done. But at the same time I try to avoid using them. This one here I 3D printed this shock mount, but I decided for this chassis to try to avoid as much of these standoffs or spacers as much as possible. And so what I did was I did this part here, so this part here, and with the captive nuts, and also one here and one in the front. And as you can see, this here, so I don't need a spacer in the shocks. It interlocks with this upper portion, so it interlocks there. This was a lot of fun to design, a lot of fun to build, not a lot of fun to cut with 1mm end mill. Not a lot of fun, but it gets done. Also, this upper, I don't know what to call this, upper portion, this upper brace, it just locks here and locks here on the side, and it's quite stiff, doesn't go anywhere. So everything works as it should. From what I've been using it's a good chassis, if I can say so myself. I'm very happy with the way it performs, so at least for that I'm good. As far as electronics go, we can start actually here. I was running one of those, what's the name, Novak systems, and it was great in terms of power, in terms of wheel speed. I was running in 2S, enough wheel speed, enough power, enough drag brake. When it was stopped, it would really stop the rig, no problems at all. The problem was going downhill. As soon if the car was already going downhill, and as soon as I touched the throttle, it would just go. So I had no control going downhill. I could not just modulate the accelerator to just go like crazy. So I decided to try an outrunner. If I remember correctly, this is 2200 kV. It's a bit big, so I had to, let's say, massage the the gearbox to fit this motor. I also had to make this motor mount plate, and it fits now. And it's, I think I was running a 13 turn, and now I moved to a 14 turn, a 13 tooth pinion, and now I moved to a 14. I still didn't test on proper rocks. I have to do that. What else? I'm running a King Max 04 CL, and great servo, doesn't get warm. It's a low profile servo. The specs are supposed to be 40 kilograms per centimeter. I don't know how much that is in ounces per inch. I mean, I don't know. I've done the calculation, I just don't remember. I don't know if it says on the gearbox. Let's see. No, it doesn't say. It just says the torque in metric system. And in metric system at 8.4 volts is supposed to be 45 kilograms, which is a lot. So this servo has the same design in terms of the gears as the Omzobis, the SHV 800, and also their new low profile. So it has, I think it's four gears or 5 gears, I don't remember, but anyway, it's one more gear than what it used to be, the old designs. So it has plenty of torque. It's not the fastest servo, but it's fast enough. I'm running a BC, Castle BC, and the electronics are, somewhere there, inside. And basically, the BC is bigger than my ESC, because I'm running, I think it's called Right 32 ESC. It's a drone ESC. It's flashed with some, let's call it crawler firmware. It's silent, so the outrunner doesn't make the whining sound. Before I was using a Mamba Micro X, also worked great, but this one it has the same footprint as the Castle 10 amp BEC, but it's lighter because it has less stuff, and it has been working great. We'll see if it starts puffing some smoke and quits enjoying life. I've run these wires, and I put another capacitor there. Let's see. So far it has been running great. We'll see for how long. Tires, I have the HB Rovers 1.9 on the rear. I also had in the front, but I was not a big fan. I wanted to try pins because I think a Mini, it's so hard to set up that I really wanted pin tires because to have smooth traction. This one, once it starts jumping, going up and down instead of moving forward, is very hard to control. The pins are less prone to have that jumping while going uphill. And yeah, these tires are from 1.8, I think 1.8 TT or 110 TT, and they are cut and shot, and then shortened and all kinds of stuff. I have another set so I can make some rears, but I've been lazy. Shocks, they are cheap Chinese stuff, but they have been working great. I think they are 60 millimeters or 70 millimeters. Basically, these used to be all blue. They have a bit of a slop, see. But other than this slop that I can live with, so up and down is not so much, it's just side to side. Up and down, not much slop. But they don't leak, and they cost peanuts. They used to be all blue. I just took the anodizing off. And yeah, soft springs on these 3 shocks, and then this one has a medium spring because it was with a torque twist. It just loads this shock all the time. Even now with this spring it's doing that. But yeah, something I live with. It's a fun little rig. A huge project on SolidWorks for me, so I had a lot of fun designing it as well, and it has been working great. I just broke one of these 3D printed, so I printed another one, the front gearbox, which I suppose is not unexpected, or should not be unexpected. And yeah, that's it. Cool rig. Hope you like it. Cheers.